All right, thank you for joining us today. And in this video, we are going to talk about the limit definition, right? And then we are going to pick examples on limit definition using polynomial functions. And we are going to see how we can go through when the function is a polynomial function, when the function is a rational function, when the function is a radical function, and when the function is a trig function. So first, I'll try and derive the limit definition formula, right? Then we dive through by taking these examples. All right, so we started the idea of limit with instantaneous rate of change and then average rate of change, and we talked about the slope of the tangent line and then the slope of the secant line. So we learned that the slope the slope of the tangent line is equal to f prime of a. That's what we learned, right? And then we also learned that the slope of the secant line, is the same as the slope of the line, is equal to f of b minus f of a divided by b minus a. So this is what you are going to use to derive the limit definition. So first, what I'm going to do is I'm going to let h to be equal to b minus a. So when I do that, then I can make, let me say, A the subject or B the subject, right? So if I'm making A the subject, then I'll move the A here, then I move the H here, right? So um, I'm going to have something like B to be equal to 8 plus A, right? So when I make B the subject, I just need to move the A to this side, right? So when I move A to this side, B will be equal to 8 plus A. Now I'll do substitution in this formula, right? So I'm going to have something like f of B is 8 plus A minus, what is A? A is still A divided by, now B minus A is H. So this is what you are going to get after change of what? Variable. Now I'm going to pick limit as h is approaching what? 0. So as soon as I pick limit as h is approaching 0 of f of h plus a minus f of a divided by h, then this is going to give us the slope of the tangent, right? This one, the slope of the tangent. We learned that when we have a secant line, right? We have a secant line like this. It has 2 points, A and B, right? But here we are using A and H. In the formula, we are using A and H. So if I make this one H, right, then what happens? When I find limit as H is approaching 0, I mean when H is approaching 0, it means that H is getting 0. Then it means that we are going to go to this side, which is the slope of what? The tangent. So this will be the formula for finding limit. This is the limit definition. So if I change variable by changing a to x, I'm going to have f prime of x to be equal to limit h is approaching 0, f of x plus h minus f of x, all divided by h. So this is going to be the definition for limit. So this is the limit definition. So throughout the examples that you are going to do, this is what you are going to use. F prime of x is equal to limit as h is approaching 0, f of x plus h, then minus f of x, all divided by what? H. So this is what you are going to use throughout our definition, right? Good. So now let's pick examples. A polynomial function first, then we go to rational function. We talk about radical function and then the sine function, then we are done. So I'm going to show you all the tricks that you need to know whenever you are using the limit definition, right? So this is a polynomial function, right? So the first thing I'm going to do is I'm going to quote the limit definition. So the limit definition is f prime of x is equal to limit h is approaching 0, f of x plus h minus f of x, all divided by what? H. So now what is the trick here? You know, anytime you are finding x plus h, sometimes if you don't take care, you will make mistakes, like when you are just putting them inside this. Because in this formula, we have f of x already. So all we need to look for is we need to look for f of x plus h, which we can derive it from this. So this is what I do. I'll pick my f of x, which is this here. And since my x here is in the parentheses, I'll make sure that all the x values here too are also in what? Parentheses. So I'm going to have something like x in parentheses squared plus 2x plus 1. So you see that they are all in parentheses. So you can see that there is x here, x here, x here, right? So that it can help me to find for f of x plus h. So x plus h, what I'm going to do is, now the one in the parentheses here is not x, it's x plus h. So I'm going to change all those in the parentheses to what? X plus h, which we are going to have x plus h squared plus 2x plus h plus 1. So what do you see here? You can see that x plus h, x plus h, x plus h, the same function, which this one was x, x, x. So this helped us to derive this, right? Good. But when you are good, you can just go through straight without putting this in what? Parentheses. But I just want to show you how you can do it and be safe without, worried about whether you are doing it right or not. So now what you are going to do is, now we have this guy here, we have this guy also here. But let's see if we can expand this function here. So this is the same as, now x plus h squared can be written as x plus h, x plus h, right? Plus, now I can distribute the 2 here. I'm going to have 2x plus 2h plus 1. Then now what I can do is I can multiply these two. So x times x will be x squared, x times h will be x plus xh, then h times x will be plus xh, then h times h will be plus h squared plus 2x plus 2h plus 1. So I can do some simplification here, which is x squared plus 2xh plus h squared plus 2x plus 2h plus 1. Can I simplify any term here? No. So now I have my f of x plus h, I have my f of x, right? So instead of picking the whole of this in place of this minus the whole of this, what I'm going to do is I'm going to take what is here and solve. Then the final result, I'll come and place it here. So now that I have my f of x plus h expanded, and I have my f of x also to be this, what I'm going to do is I'm going to find this. So let's look for f of x plus h minus f of x. So f of x plus h is what we have gotten here. So I'll just write x squared plus 2xh plus h squared plus 2x plus 2h plus 1 minus. So in math, anytime I write minus, whether the function is just one variable or a number, I just make sure I put it in what? Parentheses. So I'll put this one in parentheses. Now what is f of x? F of x is what is here? X squared plus 2x plus 1. So I'm going to have x squared plus 2x plus 1 in parentheses nicely, so that minus can distribute here. So I'm going to have x squared plus 2xh plus h squared plus 2x plus 2h plus 1 minus x squared minus 2x minus 1, right? So we can see that x squared cancel, 2x cancelled, 1 and 1 here cancelled. So what will be left? it will be left with 2xh plus h squared plus 2h. So that is what is going to be left. Now, anytime you do simplification for this function here and you do it well, when you finish, you should be able to factor what? H out. That is another trick that you need to remember. When you do it very well, you should be able to factor h out after you are done doing the subtractions. So here now I can see that I have h here, h here, h here. I can factor one of them out. So this one will be h out 2x. Now h squared is the same as h times h. So when I factor one out, it will be left with h, and then 2h will be left with 2. So this is what I'm going to have for this, which is on the top right here, right? So I'll move this one down small. Good. Then now we'll come and work on this. So now this will be equal to limit h is approaching 0. Now what is f of x plus h minus f of x? That's what we had here. This and is equal to this. So I'm going to write this on top there. So we are going to have h 2x plus h plus 2 plus 2 divided by h, right? And fortunate for us, h will cancel what? H. So we are going to have limit h is approaching 0, 2x plus h plus 2. Now we can plug in the what? The h is 0, right? Because here the reason why we couldn't plug in the when h is approaching 0 is when I plug in 0 here, the function becomes what? Undefined. So in other terms, when we started learning this, we saw that whatever is here is the average rate of change. So this is average rate of change. And when I pick limit as x is approaching 0, the final result I'm going to get here is the what? Is the instantaneous rate of change, right? So that will be the slope of the secant line, right? Sorry, the tangent line. So now let's plug in h, 2x plus 0 plus 2, and this is going to give us 2x plus 2. So this will be the final results for this. And then another trick that you need to know from here is that as I'm going to show you how to do differentiations, one thing that you can always confirm is when you use the limit definition, always when you are done, you can differentiate the function straight to see if it's the same as your results. So now let's try and differentiate this and see if we are going to get the same thing as this. So that's another trick of, you can use to verify your solution. So what is f prime? Using the power rule. If you don't know the power rule, I will start doing power rule very soon, right? From here we will look at, and from this video we look at the properties of what differentiation, right? So product rule here, when I differentiate x squared, I'm going to have 2x plus, when I differentiate 2x, 2 is a constant function multiplying x, so I'll just bring it out and differentiate s and get 1. When I differentiate a constant which is 1, I'll get 0. So this will be 2x plus 2, which is the same as what is here. So that is another way. So when you are done with the limit definition, what you need to do is you can differentiate the function to check if your results is what? Right. Good. So that is the idea. Even if, let me give you another trick, even if maybe you've done everything, you've made some mistakes, and you check the differentiation and this was not the same as this, and there's no time, you can just write this one as your final results, and at least you should be able to convince the lecturer that okay, you had the final results there, but you've done something which shows that you didn't just differentiate the function to give him or her the final results. So this is the trick when you are using the limit definition to compute what a polynomial function. Now let's look at when we are using the limit definition to also compute a rational function. What are we going to do, right? So the same idea, let's write the limit definition down. f prime of x is equal to limit h is approaching 0, f of x plus h, f of x plus h minus f of x, all divided by h. So that's the first thing that you need to write it down, like whenever you are doing it. So now we have f of x, which is here, right? So we need f of x plus h. So as usual, I'll put all my x's in what? Parentheses. So 1 divided by 2x plus 1. I put them in parentheses because this s here is in parentheses, this s here too in parentheses. Somebody will ask, what if the function was given like 1 over 2x plus 1? What am I going to do? What I'm going to do here, for me to see it very well, I'll just make y to be equal to f of x, so that when I write it this one, I can also put the x into parentheses. So x here, the same thing. So this now is going to help us to find f of x plus h, right? So now the one in the parentheses here is now, it now has changed to s plus h. So the one in the parentheses here will also change to 1 plus h. So I'm going to have 1 divided by 2x plus h plus 1. So this is what I'm going to get. So now I have my f of x plus h and I have my f of x. So as we like doing it, instead of placing this one here minus this, I'm going to pick the one on the top here, simplify it, and then now I'll come and put it there. So now let's look for f of x plus h minus f of x, right? So this is what we need to look for. So let's look for this one. This is equal to, let me bring this one here down here. Good. This is equal to, now f of x plus h is equal to 1 divided by 2x. So let me simplify this here. This is going to be 1 divided by 2x plus 2h plus 1. Good. This is what I'm going to get for that one. So to be 2x plus 2h plus 1 minus, now f of x here is this. So this is 1 divided by, so when I simplify, when I multiply this, I'm going to have 2x plus 1. Good. So here is my technique. I used to, do fractions. And as soon as you learn this technique, you should be able to do all fractions, right? Good. So I'm going to show you. Good. So this is how I do my fraction. It goes like this. First, so I write here first, right? Second, so look at the pattern. Second, then third. Good. So anytime you have this pattern right here, you have it in mind. You should be able to do all fractions. So what did I do? How is it going to apply to this function here? So you see, first is this, right? The right diagonal like this. So it goes like this. So it means that the one on the top here times this, like this, which is the first. So I'm going to have 1 times 2x plus 1 minus, so I have my minus here. Then second, that is the left diagonal. So this times this. So I'm going to have 1 times 2x plus 2h plus 1, right? And then the third one is like this. So the third one is like this times this. But it's going like this, so we need to divide. So divided by, then this one. So that's the third one. So third one is like vertical. Did I say vertical? Horizontal, right? So like this. So I'm going to have 2x plus 2h plus 1, then 2x plus 1. So this trick, you can just use it to do any other fraction that you want to do. And you see that it's going to work for you. So this times this here minus, so the sign here, if this one is plus, you put plus here, right? And then minus this times this, which will be here, then all divided by this times this. Very simple. So that's what you are going to do to get your result. So this one, now if you want to expand, 1 times this is going to give us 2x plus 1. Then minus 1 multiplying through this is going to give us minus 2x minus 2h minus 1, all divided by 2x plus 2h plus 1, then 2x plus 1. So what happens here? Minus 1 and 1 goes, 2x and this one will go. So I'm going to have something like minus 2h divided by 2x plus 2h plus 1, 2x plus 1. So this is what I'm going to get. And you see, anytime I do something like that, I should be able to factor h out. So here, I can easily factor h out, but because it's just one function, it can be there like that. So now this is equal to this. So now when I go back to where the function is, I'm going to have this one to be equal to limit h is approaching 0. Now what is f of x plus h minus f of x? This is this, which is equal to what we had here. So we are going to write this on the top there. So this is minus 2h divided by 2x plus 2h plus 1 times, I think, 2x plus 1, right? So everything here is just the one on the top. So we are going to divide it by what? H. But instead of writing divided by h, this division here, I'm going to make it divided by h instead of doing divided by h, right? I'm going to do it divided by h. So this is what I'm going to get, divided by h. So that now I can write this one as limit h is approaching 0 minus 2h divided by 2x plus 2h plus 1 times 2x plus 1 times 1 over what? H. Right. So when I do that, now h cancels h. So one thing about limit definition is anytime we do the simplification, we should be able to cancel the h, which is making the function undefined. Like when I plug in 0 here, I should be able to cancel it out, so that now when I finish canceling the h out, I'll be able to put the h in to get what? The final result. So you saw from the polynomial, we were able to cancel h out and we're able to do direct substitution from there. So now that we've cancelled the h out, what will be the function? Limit h is approaching 0, then to be left with minus 2 divided by 2x plus 2h plus 1, then 2x plus 1, right? So now I can put my function in, like my h is equal to 0 inside the function. So I'm going to have something like, when I plug in 0, I'm going to have minus 2 divided by 2x plus 2 times 0 plus 1, then 2x plus 1. So what am I going to get at the end of the day? I'm going to have minus 2 divided by 2x plus 1, 2x plus 1. And since this term is the same as this term, I can write this one as negative 2 divided by 2x plus 1 all squared. So this is what we are going to get when we use the limit definition to do this. Now, quickly, I can differentiate this and confirm if it's going to be the same as this. That's what I can do, right? So that is the idea with checking. So this one, we can either use the quotient rule, or we can use the chain rule, right? It's the same thing. If I want to use the chain rule, then I can write this one as 2x plus 1 all to the power minus 1. Then we use the chain rule, right? But since we are going to do more on derivatives, I will just leave it like this. But the idea or the trick is, whenever you are done, make sure you do the straight differentiation to check if this one is the same thing. So let me just do it straight. So what will be f prime? F prime of x will be equal to, chain rule says that with this one, we are going to drop the minus 1, right? Then I'll maintain everything in the bracket. Like here, I'm applying the power rule. Then it will be minus 2, right? Because when I drop the minus 1, I maintain the function and subtract minus 1. So minus 1 will be what? Minus 2. Then I'm going to multiply this one by, when I take the derivative of what is inside the bracket, which is going to give us what? 2. When I simplify this, since this one is minus, I can bring it down. So I'm going to have minus 1 times 2, which is going to be minus 2 divided by 2x plus 1 all squared, which is the same as what we had here, right? So always confirm by checking. Now let's go through when we have a radical function. So from here, we are going to look at when we have a trig function. So learn all the trigs together, and each function you should be able to do it. No matter how they are going to modify the function, you should be able to do it right. So the same idea, let's go. F prime of x is equal to limit h is approaching 0, f of x plus h minus f of x divided by 8. So don't forget the limit definition, because always if you forget about the limit definition, then it means that you cannot do this question, because we need it. So now I have my f of x, which is equal to root of, so I'm putting all my x in parentheses, so 4 minus 2x. Then this one will help me to find for x plus h. So with limit definition, always we have our f of x, and then we need to find f of x plus h before we simplify. So this is going to be root of 4 minus 2x plus h. So because I put this one in parentheses, x here in parentheses, x here in parentheses, using the same function, x plus h in parentheses, x plus h in parentheses. Wow. So now what can we do? We can simplify this, and we are going to have 4 minus 2x minus 2h. Right. So as I said, instead of putting this one here minus this, we are going to pick the top, simplify, then you put the final results there. So let's go through that. Now f of x plus h minus f of x will be equal to root of 4 minus 2x minus 2h minus f of x. So this one is one function. So instead of putting in parentheses, I will just leave it like that. So 4 minus 2x. Now, can we simplify this? Yes, we can simplify this. So anytime I have a radical function and I write it in this form, this is what I need to do. I'm going to multiply this function by 1, but not just 1. But what I'm going to do is, we have two radicals here. One is here, another one is here. We look at the sign between them. This is minus. So I'm going to write the same thing here, but I'm going to change the sign here to what? Positive. If this one is positive, when I write the same thing, I'll change the sign to what? Negative. So this is going to be root of 4 minus 2x minus 2h plus root of 4 minus 2x divided by root of 4 minus 2x minus 2h plus root of 4 minus 2x. So you see, now this divided by this will be 1. So it's like I've multiplied the function by 1. Now let's assume that this one was positive. Then I'll change this one to negative, change this one to also to negative. So now since this one is negative, this one should be positive, this one too should be positive. Very simple. So now what are we going to do? Now we are assuming that this here is divided by 1, right? So the 1 will multiply the 1 at the denominator here, and then the top will also multiply the top. So let's simplify. We are going to have this function multiplied by this function. But you can see that what is under the root or the radical is the same as this. We know that if I have root of a times root of a, this is equal to a. So it means that since the one under the root are the same, and we are saying that it's a, this and this are the same. So I'm going to have 4 minus 2x minus 2h when I multiply this and that. Now, one bonus thing that you always find when you are dealing with radical function and you pick the conjugate, or you rationalize it and you want to do it, is that when I multiply this one by this, the last term here, and multiply this one by this, they are going to cancel out because of the minus and then the positive. So anytime I'm doing rational function like this, what I do is I just multiply this to this and multiply this to this. Because when I do the other ones, they are just going to what? Cancel out. So I don't need to even write them. So instead of multiplying this by this minus this by this, it is going to cancel out. So I'm not going to multiply. So I'm going straight with this and that. So this one is going to be minus. I'll put it in what? Parentheses. Now this and this are the same. What is under the root is the same as what's under the root here. So I'm going to have 4 minus 2x. all divided by, I said this is divided by 1, so 1 times the whole of this is going to give us root of 4 minus 2x minus 2h plus root of 4 minus 2x. So let's simplify. I'm going to have 4 minus 2x minus 2h minus 4 plus 2x divided by root of 4 minus 2x minus 2h plus root of 4 minus 2x. Now, this will cancel this one too will cancel that. So, fortunately for us, we are going to have minus 2h divided by root of 4 minus 2x minus 2h plus root of 4 minus 2x. So this is what we are going to get for the top, right? The whole of this, the same as what is here. So now what we are going to do is we are going to pick the formula here and then we do substitution. So let me pick this one down, right? So that we can do the substitution. Good. Let me pick this one down here. So now what is happening here? Now I'm going to have limit h is approaching 0. Now f of x plus h minus f of x, which is this, is what we've simplified to get this. So I'm going to write the whole of this on the top here. So I'm going to have minus 2h divided by 4 minus 2x minus 2h with the root plus root of 4 minus 2x. So as I said when we were doing the rational function, we said since I'm going to divide this one by h, instead of doing this, I'm going to just do it this, right? So I'm going to divide it by h, right? So that now this will be limit h is approaching 0 minus 2h divided by root of 2x minus 2h plus root of 4 minus 2x times 1 over h. Then h will cancel the h, right? So that now when h cancel h, then I'm happy because now I can plug in when h is approaching what? 0. So this is going to give us limit h is approaching 0 minus 2 divided by root of 4 minus 2x minus 2h plus root of 4 minus 2x. So now I can plug in h is approaching 0, right? So minus 2 divided by root of 4 minus 2x minus 2x, 2 times 0, and then plus root of 4 minus 2x. So what are we going to get here? I think I can push this one on the top small so that we will see how we can do that. So let me just shift this one small so that we can just do the last simplification for this. So when I shift this one up, good, I'm going to have this one to be minus 2 divided by, so this will be 0. So I'm going to have root of 4 minus 2x plus root of 4 minus 2x. So you see that what is here is the same as what is here. So if I have root a times, plus root a, this is the same as 2 root a, right? We saw that root a times root a was equal to a, but root a plus root a is the same as 2 root a. So this is going to give us minus 2 divided by 2 root of 4 minus 2x. Then I can cancel the 2 out. So my final result should be minus 1 divided by root of 4 minus 2x. Good. So this is what I'm going to get at the end of the day when I'm dealing with the radical function. So one way of confirming this is also by differentiating this function using the change rule, right? So the idea is that when I'm done using the limit definition, I should be able to confirm by using the limit definition. Using the direct differentiation. So let's do that. This one can be written as 4 minus 2x to the power 1 over 2. Let's use the chain rule to do that. What are we going to get? F prime of x. First, I'm going to apply the power rule. So half drops down, 1 over 2 drops down. Then I have 4 minus 2x to the power 1 to the power 1 over 2 minus 1, which is going to give us minus 1 over 2 times, then I differentiate what is inside the bracket, which is going to give us negative 2. So these 2 will cancel these 2. So I will have minus times 1, which is going to give us minus 1 divided by, then this one will come down and come and have something like 4 minus 2x to the power 1 over 2. And this is the same as minus 1 divided by root of 4 minus 2x. And this is the same as what we had here, right? So this is another way of checking, right? Always when you are done, try and differentiate the function to see if indeed you did the thing right, right? So let's talk about the last example here, a trig function, right? So we want to use limit definition to also check trig function. So this will be the last example here, and then we will start with the rules of differentiation, right? And in maybe some videos, you will take more examples on how to do limit definition with different functions. Practice more, right? So this one, the same idea. Let's use the limit definition. F prime of x is equal to limit h is approaching 0, f of x plus h minus f of x divided by h, right? So this is what we have. So we have f of x. Good. So this one, we are fortunate. X is in parentheses. This s is also already in parentheses. So I just need to look for x plus h. So using the same function here, I'm going to have sine x plus h. Good. So what do I need? I need f of x plus h minus f of x. So f of x plus h minus f of x is equal to sine x plus h minus sine x. Now, the reason why I mostly, simplify this before I put it here is, you see, when I place this one here, right, I need to go and write limit, then I'll be simplifying this. You'll be tired of writing the limit. So I like picking the top, simplify it. When you get your final result, come and place it here, then you are done. Now, how are you going to simplify this? Now, we need to use trig identity, right? If you remember trig identity, we have sine of, so let me write it above here so that you can see sine of a plus b, which is the same as, we can expand it to have sine a cos b plus cos a sine a. So this is the trig identity that we need to use. Now our a is equal to x and our b is equal to h. So we plug them in here and then we are done. So this will be sine x cos h, right, minus, plus cos s sine h, right? So after the expansion, minus sine x. So this is what you are going to get at the end of the day, right? Good. So right now, what we are going to do is we are going to group like terms. So I can see sine x here, I can see sine x here, right? So what I'm going to do is I'm going to combine them together. So I'm going to have sine x cos h minus sine x, right, plus cos x sine h. So this is what I'm going to get, which is very nice. Now let's look at something here. I can factor sine x out. So I'm going to have sine x. Then here we'll be left with cos h minus 1 plus now sine x, cos s sine h. So this is what I'm going to get. Yes. So at the end of the simplification, this is what I had. So I'm going to place this one inside the limit there. Then we use the limit property to try and then work out this, right? So if you've watched my video on how to evaluate limit of a trig functions, right? Limit of a trig functions, you will learn some of the properties that I'm going to use from here. So now what is f prime of x as limit h is approaching 0 of f of x plus h minus f of x divided by h. This is the same as limit h is approaching 0. Now f of x plus h minus f of x is equal to what is here. So I write everything on the top there. Sine x cos h minus 1 plus cos s sine h divided by h. So the whole of this divided by h. Somebody will ask, why is it that this one we didn't do it divided by 8? Because this is like, it's not in the form of a rational, right? It's like this divided by something. So if this is divided by something, then we will do this one by divided by h, right? So now let's apply the trig properties that we learned from one of my videos, right? So you can go and check it out, how to evaluate limit of a trig functions, so that you understand this one better, right? So now we also learned that a limit of a constant is the constant. So don't forget. So I'm going to do something here. So you can go and check out my videos on that. So this is the same as cos h minus 1 divided by h plus cos x sine h divided by h. So I can split this one into 2 because of the addition sign here. So h divided, this divided by h, this divided by h. Right. Now here is limit as s is approaching 0. So this is a constant function because it does not depend on what? H. So first, let me write this one as limit as h is approaching 0 sine x cos h minus 1 divided by h, limit property, plus limit h is approaching 0 cos s sine h divided by h. So this is the limit property. When you want to find limit of two functions, adding, we can pick limit of the first function plus limit of the second function, right? Now, as I said, since this one does not depend on h, it's a constant function, so I can factor it out. So sine x out, then I pick limit h is approaching 0 cos h minus 1 divided by h, plus here cos of x is also a constant function because it does not depend on h, so I can factor it out, and then this. So now we remember from one of our property that we learned that if I pick limit as s is approaching 0 of sine x divided by x, this is equal to what? 1. So you see that there is s here, there is s here, there is s here. So when you look at this one, there is h here, h here, h here. So automatically this is going to give us 1. So this is going to be like plus cos s times 1, right? Now we also learned from one property that limit as h is approaching 0 of 1 minus cos s of x divided by x, this is equal to 0. But we can see that this one is like a swap, right? So now we know that if I have something like this, this can be written as limit h x is approaching 0. Now here, if I factor minus out, I'm going to have minus 1 plus cos s divided by x. And this is the same as, I can factor the minus out. So minus limit s is approaching 0. Then when I interchange this and this, I'm going to have cos of x minus 1 divided by x, and this is the same as minus times 0, which is also 0, right? So because we can swap it by minus and it's 0, still we are going to get 0. So this one here too will be what? 0. So it means that we are going to have something like this. Sine of x times 0 plus this here. So 0 times sine will be 0 plus cos of 1 will be that, and then we are going to have that. So remember that when I differentiate sine x, I get cos s. So that is the idea of limit definition, right? The principles of differentiation. So the first principle, that's the limit definition. That's what you are going to get, right? So yeah, so you can have more fun. You can write some of the function on by yourself, either trig function. You can try cos function, but with the cos function, don't forget when you are expanding cos of a plus b, you are going to have cos a cos b minus sine a sine b, right? Good. So you can try the cos function, and then you can pick a radical function, let's say root of x. You try it. You can try a rational function like 1 divided by x. You try it. Then you can pick a polynomial function like, let me say, f of x is equal to, let's say, 3x squared plus 1. And then you also try to make sure that you are okay with the function. All right. So see you in the next video where we are going to talk about properties of what? Differentiation.